Hello and welcome to our final project presentation. We are Group E, and our project is to make a speaker amplifier and obviously the power supply that comes with it. And our group consists of Ahmad Zaki Jamaluddin, Corey Giekti, which is me, Kevin Pradipta, and Sylvia Nachal Zahira. And I will briefly explain what our circuit is actually about first, what we're trying to make, and then my friends will explain it more in detail. So, in short, we're just trying to make a amplifier circuit or a speaker amplifier circuit that receives input from a 3.5 millimeter jack that you can connect to your phone or your laptop or whatever device, and it takes that small signal and amplifies it so that the speaker can play it loud and clear. And our other half of the project is making the actual power supply to supply this amplifier. So how that'll work is we have to use the power outlet from the actual wall and turn that big AC voltage and turn it into a smaller, safer DC voltage. And that's, in short, that's kind of the whole thing. And we chose to use a standard linear regulated power supply for the power supply. And it's single rail. And why we chose to do this is because it's kind of the simplest and easiest to implement, and there's only one regulator, and it just makes everything easier to calculate as well and easier to implement, and that's kind of it. And why did we choose class AB amplifier for our amplifier, or our actual amplifier circuit? Is, well, most speakers use AB because if you might know that the class A amplifier has just one transistor and it just keeps it on and has to amplify it consistently, and it's just not efficient. And the class B has two transistors and it amplifies, one of them amplifies the positive only and one of them amplifies the negative only, and that is quite efficient, but it'll cause distortion, like this crossover distortion here, and we don't want that when we're trying to do sound. And so we use the AB, which is kind of a mix of both. So one of the transistors will only amplify the positive and a little bit of the negative cycle, and vice versa with the other transistor. And I will, and my friends will explain the actual circuit more in detail. So yeah.
Okay, so my name is Kevin, and today I'm going to explain about this Fronteo simulation. So this is the wall socket, this transformer, this is the bridge, capacitor, and a IC7812. So this is pretty much just a AC to DC converter, or just a 12-volt power supply. And this is the audio jack, pretty much. We're just simulating with a sine generator, and it's gonna output in this AB amplifier, and this is pretty much the output where we can see this. The A is the original, the blue is the amplified one, and this is the potentiometer to control the audio. So if you press play, and so this is gonna be the blue line, this is gonna be the amplified line, and if we increase the potentiometer, it's gonna go down very quickly, and then yeah, and then if we go back again, it's gonna increase again. So that's just pretty much how the circuit simulates and how it works. The line is not as smooth yet, but that's pretty much how it works.
Okay, so I'll explain the main components used in our speaker amplifier circuit. So first is the 1458 operational amplifier. Its a function is to amplify the weak input audio signal before it enters the transistor stage. And next is the 50 kilo ohm variable resistor, which acts as the volume control. By adjusting it, we can control the input signal amplitude. And for the transfer section, we use the tip 31 and tip 32. transistor in a push-pull configuration. So the tip 31 is an NPN transistor, and the tip 32 is a PNP transistor. So these transistors are responsible for amplifying the positive and negative half of the audio signal. We also use the coupling capacitors to block DC voltage while allowing AC audio signal to pass through safely. And finally, the speaker converts the amplified electrical signal into sound output.